my name is Leon, and today we're going to learn about the physics of music and sound.
Hi, I'm Vishnu. You may think that music and art and physics and science are vastly different, but you'd be mistaken. Music and physics are very much intertwined, and today we hope to show you that relationship.
Sound is a wave. A wave is defined as a disturbance that travels through a medium and transfers energy. For sound, the medium is usually air, but can also be liquids and solids. Sound is a mechanical wave because it involves particle-particle interactions. Unlike electromagnetic waves, which do not require a medium to travel through, sound waves require a medium to travel through. Sound waves are also considered pressure waves because they are not represented by troughs and peaks, but rather of areas of compressions and rarefactions. Compressions tend to push particles together and are considered areas of high pressure, while rarefactions tend to pull particles apart and are areas of low pressure.
The period measures the time between successive compressions and rarefactions. The frequency of a sound wave measures how often particles of the medium vibrate when a wave passes through them. The frequency of sound is a measure of the pitch and has units of hertz. The diagram here represents pressure versus time, so the troughs and peaks depicted are not actually troughs and peaks of the wave.
There is a simple relation through which we can determine the factors affecting the frequency of an object. Known as the frequency-wavelength relation, this relationship states that the speed of the sound wave equals the frequency multiplied by the wavelength. Therefore, all three quantities are directly or indirectly related.
Every object has an optimal or natural frequency where it will vibrate without continuous external stimuli. This is known as the natural frequency of an object. In fact, the sound quality of an object, known as timbre, is highly dependent upon its natural frequency.
When an object vibrating at the natural frequency of a second object forces that object into vibration, this induced movement is known as resonance. Notice that one tuning fork vibrating at 440 Hz induces another tuning fork also set to vibrate at 440 Hz to vibrate.
In the field of music, musicians must control the frequencies of their instruments to produce their desired sound. They accomplish this by adjusting the various factors affecting frequency. For example, a guitar's frequency is dependent upon three factors: tension of the string, length, and linear density. Resonance is dependent on how these factors are changed.
Pleasant sounds are produced when two notes have a whole number ratio between their frequencies. Octaves have a 2-to-1 ratio.
And those are octaves.
Thirds have a 5-to-4 ratio. Fourths have a 4-to-3 ratio. And fifths have a 3-to-2 ratio of their frequencies.
The greater the amplitude of the sound wave, the more energy in the medium, and thus there is a greater intensity of sound. Intensity of sound is associated with loudness, although the two terms are not totally synonymous.
Sound travels fastest in solids, at an intermediate speed in liquids, and slowest in gases. Solids have the most elastic properties out of all the phases of matter, and thus have a greater tendency to maintain their shape.
Interference of sound waves occurs when two waves meet while traveling in the same direction. Constructive interference occurs when waves reinforce each other and thus have matching patterns of compressions and rarefactions. Destructive interference occurs when waves cancel each other out and thus no sound is produced. Antinodes are defined as regions where constructive interference occurs, and nodes are defined as regions where destructive interference occurs.
The lowest frequency an object can produce is often known as its fundamental frequency. The wave of a fundamental frequency only contains two nodes and one antinode. This wave can also be known as the first harmonic. Each harmonic, first, second, third, etc., contains that number of antinodes and one more node. For example, the third harmonic contains 3 antinodes but 4 nodes.
Beats are periodic fluctuations heard in intensity when sound waves of similar frequencies interfere. Beats are associated with waves whose amplitude is changing from 0 to large amplitude.
If you've ever studied the physics of sound, you've most likely heard of the Doppler effect. The Doppler effect is the perceived upshift in pitch when an observer and source of sound move towards each other, and the perceived downshift in pitch when an observer and source of sound move away from each other. It does not involve an actual shift in frequency of the source.